Hello, everyone. Welcome back. Today we are going to be talking all about exponential decay. So, last time we talked about exponential growth, right? When something grows at an exponential rate. This time we'll talk about exponential decay. So, just like with exponential growth, it grows faster, 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 and faster as time goes on. With decay, it actually decays the most in the first time period and then decays less and less and less and less in the future. For example, we're going to get into some financial examples here, but before we even do, I want to just discuss general examples. So, in general, if we purchase a home, it goes up in value, right? Exponential growth. If we purchase a car, exponential decay, it goes down in value, right? It usually goes down in value more in the first years than in the later years, right? Or, for example, let's say we think of an item at a store, even just as an example. Let's say the item at a store costs $100 and you have a 30% off coupon in your pocket that includes sale items, and it's also 30% off initially. Okay, so originally it's $100, then we go down to $70, so we scrape off $30 from the price, and then we also use our 30% off coupon. So we're taking 30% again off of our new price of $70. So $70 times 0.7, because 30% off, now it's $49. So in this case, we only got to subtract 21 the second time, right? We didn't get to subtract the full $30 again, because each time that we apply this process of multiplying by 0.7, right, taking that extra 30% off, we now have a lower number we're working with. And so it's still decaying every time that we apply this, but it's decaying at a slower and slower rate, right? So that's important to keep in mind. Okay, so let's go ahead and try this example here. Example. And actually, let's take a look at this first. So here we have very similar to the last ones, where we have current and future value, or initial and current value. So again, sometimes we might be given a current value and we're told, okay, here's the value currently. What was the value 10 years ago? What did the value used to be 10 years ago if it's depreciated at this rate, or it's decaying at this rate? Or we might get a question of, okay, today we're going to buy our vehicle for $10,000. In 20 years, how much will the vehicle be worth? Spoiler, probably not a lot. Probably not a lot in so many years, if it's even working at all, right? And so there's two different types of questions. So these two go together. It's either we're doing current and initial together, or we're doing future and current together, depending on the type of question, right? Depending on whether the question's asking, oh, here's the amount today, what was it worth 10 years ago? Or if it's, here's the amount today, what will it be 10 years down the road, type of thing. Or either one of those values could be for us to find as well, potentially. Okay, so let's give this a try. It says, when you buy a car, its value begins to decrease. Well, that's true. Okay. Suppose you buy a car for $15,795. It depreciates in value at 15% per year. How much is it worth in 6 years? Okay. So first I want to figure out what are A, P, I, and N. That's my very first step here, is figuring out all of these values. So what's A, first of all? Well, it says you buy a car today for $15,795. So how much is it worth in 6 years? So that means we're using current value is $15,795 and future value. So actually A, we do not know. A is going to be our future value in this case, and that's the question we're trying to answer. That's what we're trying to figure out, is what is A. So we don't know, right? We're allowed to put a question mark on one of these because that's the one we're trying to find. Okay, so P, which is our initial value, or I guess our current value, I should say, is $15,795. That's how much we purchased it for today. I is 15% per year. So that means it's negative 0.15 would be I, because it doesn't go up in value 15% a year, so it's not plus 0.15, it depreciates in value, so it's going down, so it's negative 0.15 is our rate. We're losing 15% every year. How much is it worth in 6 years? So n is number of years, so pretty straightforward that n would be 6. Okay, well now let's figure out the answer. A is equal to 15,795. 1 plus negative 0.15 to the power of 6, which is equal to 0.85 to the power of 6. All right, so let's see what that is. 0.85 power of 6 times 15,795 is going to leave us with about $5,957 and 7, or I guess 8 cents. So as you can see, this vehicle has went down in value by more than half overall. Right, it's gone down in value by quite a lot, unfortunately, by around, I guess, close to $10,000. So the vehicle today, in 6 years, the vehicle today is worth $15,795. Right, that's what you're buying it for. In 6 years, it will be worth $5,957.08 is our estimate. So therefore, in 6 years, the car will be worth only $5,957.08. Very good. Okay. The next example says, suppose the car you purchase for $10,000 loses 10% of its value each year. How long until it is only worth $7,500? Okay, and this question is exactly why we did the logarithm lesson before now. So if you're unfamiliar with logarithms, do make your way over there because this question will involve using logarithms. Okay, so let's find out what are A, P, N, and what was the last one? I. There we go. Okay, so A is our current or future. In this case, we purchase something today and in the future it's worth something else. Okay, so this one's current and future then. So therefore A would be 7,500 and P would be $10,000. N is how many years, and that's what we're trying to figure out. It says how long until it is only worth 7,500. So that's what we want to know. So that's our question mark for this question, is we don't know how many years. That's what we will figure out and conclude about at the end. And then I is the interest, the depreciation rate, I should say. I is the percentage increase as a decimal. In this case, it's losing 10%, so it's going to be minus 0.1. It'll only retain the other 90% of its value if it's losing 10% of its value every year. Okay, so let's put this in. So A, or actually I should just plug it in the number right away. 7,500 is equal to 10,000. 1 minus 0.1 to the power of n. So therefore we have 0.75 equals 0.9 to the power of n. And we might not really know where to go from here if we haven't done logarithms. So again, if you haven't learned logarithms yet, I have a whole video about that. But I'm going to assume that you do know logarithms and that you have an understanding of them, that you've seen that video, and go from there. My next step is to turn this into logarithm form. So this means that log with the base 0.9 to the power of 0.75 equals to n. That means n is equal to log 0.75 over log 0.9. And let's see what that is. So negative 0.1249 over negative 0.04576 equals 2.73 approximately. So therefore, it will take about 2.73 years for the car to be worth only $7,500. Very good. All right, so those were some financial questions. And actually, Unit 4 is the financial unit. So we will be going over that again, which is the great thing, in the future at some point. Okay, let's talk about radioactive decay. So this is when we have a half-life. So in this case here, we have a mass at a specific time. Then we have the initial mass at time 0. We have t for the length of time that has passed. And we have d, which is the half-life. So how often does this half-life happen? How often do we lose half of our mass is basically what they mean by the half-life. Now this is more of a physicsy type thing, not my thing as much as the financials, but we can still kind of use the same logic of, okay, here we lose half our mass every time this half-life happens, essentially, right? And that depends on how much time it takes for this to happen. Okay, so let's read example 1. A nuclear reactor yields 100 grams. Okay, that sounds like initial mass of plutonium 239. How many years are required for the sample to decay to 25 grams? Okay, sounds like MT is 25 grams, right? We're going down to 25. And the half-life of plutonium is 24,100 years. Okay, so sounds like half-life D is 24,100 years. And then T is the thing we don't know, right? We don't know length of time that's passed. They literally ask how many years are required. So what that means to me is that they want to know the time. They want to know the time. So let's figure it out. M of t is 25. So 25 is equal to 100, a half, t over d. So therefore we have 0.25 equals 0.5 to the power of t over 2 for 100. And we know this one, we actually have a choice here. We could use logarithms for this, or we could just say, well, I know that 0.5 to the power of 2 is going to give us 0.25. So if I can just get this number to be 2, then we're good. So we could even just say t is equal to 48,200, because if we divide that by 24,100, we'll get 2, and 0.5 squared is 0.25. So this one we don't even necessarily have to use. We don't even necessarily here have to use that fancy method of logarithms, because it's very obvious here what the answer is just by looking at it. So therefore, it will take 48,200 years to decay to 25 grams. Very good. Very, very good. All right. All right, let's try this next one. And I mean, there's only one more question, so I might as well answer it. I do encourage you to pause and try to answer for yourself, but I will answer this one. No point in not answering this one. Okay, carbon 11 has a half life of 20 minutes. Okay, so D equals 20 minutes. The initial mass of the substance is 700 milligrams. Okay, so M naught is 700. How long would it take to reduce to 50 milligrams? Okay, and again, T, we don't know. We're not really sure. Okay, so let's do it. Let's see. So 50 is equal to 700 times a half to the power of T over 20. Awesome. Like that. Then we're going to convert this to logarithms because this one, it's not very obvious to me. At least maybe it's obvious to you. It's not obvious to me what t would be just by looking at this. So let's use logarithms here. Logarithm with a base 0.5 to the power of t over 20. So therefore t is equal to 20 times logarithm 0.0714 over logarithm 0.5. Okay. So let's see, what's that? 0.0714. Okay, so that's 20 times negative 1.1463 over log 0.5. So negative 0.301 is 76.166. All right. So therefore, it would take 76.166 years to reduce to 50 milligrams. I don't have space to write that, but that's the idea. Actually, maybe I'll write it here. Therefore, it will take 76.166 years to reduce to 50 milligrams. Very good. All right, well, that is it for exponential decay. Hope you all enjoyed, and we'll see you later. Bye for now.